Hey kids, this is Dr. Rones. We are going to keep on going with our chapter and move along to absolute value equations and inequalities. But we're going to pull in a lot of the stuff that you've already learned this chapter. It's going to be all one big, beautiful thing. But before we get started, just remember, I do my best to make a good video for you, but they're not perfect. Another math teacher might do a little bit different, and that's totally fine. This is just the high points from our lessons to get you going from home in case you missed a lesson or need a little refresher. So let's first talk about equations and absolute values, or even back up further than that. What is an absolute value? You may have seen these before. It is a number that's written within two vertical lines, and it means the distance that a number is from whatever number is within those two lines. So the distance that 3 is from 0, well, if this is 3 and this is 0, that's going to move 1, 2, 3 places. The absolute value of 3 is 3. Okay. Let's try the absolute value of negative 3. How far is negative 3 from 0? Well, here's 0, 1, 2, 3 again. So the absolute value of negative 3 is also positive 3. Or we could say, almost the reverse of that, the reverse of what number is 3? The reverse of what number is 3? Well, we just showed above that the reverse of both positive 3 and negative 3 is 3 places. Both negative 3 and 3 are 3 places from 0. So when we are trying to solve an equation, we are trying to say, for example, the absolute value of x minus 2 is 5. It means what is the value of x so that the left evaluates to a distance of 0 from 5. So the way that we're going to do that is we're going to use a positive angle and a negative one as well, because there's a positive distance from 0 and a negative distance from 0. Positively, we just bring down the absolute value equation straight down as it is. However, we just drop the absolute value signs. And then the negative way, we do the same thing, x minus 2 equals, but we're just going to make this into a negative 5, like so. And then we'll go ahead and solve out. Get x by itself. Reverse of a negative 2 is a positive 2. What I do on one side, I do to the other. X is 7. The reverse of negative 2 is a positive 2. What I do on one side, I do to the other. X is negative 3. Now when we put that back in, 7 minus 2 is 5. 5 is 5 away from 0 on a number line. Good. Negative 2 minus 2 is negative 5, and negative 5 is 5 places away from 0 on a number line. Kind of neat, huh? Let's try another one. If I have absolute value signs here, but then another term with it, the best thing that we should do is to first deal with that extra term. Sorry, that was a negative. I tried to make it positive. What I do on one side, I do to the other. So this problem is also 2x minus 7, the absolute value of that, equals 9. And from there, we can solve it in, again, the positive and the negative ways. So 2x minus 7 is 9. That's from the positive direction. And then 2x minus 7 equals negative 9. That's for the negative side. And then just solve it as normal. So here I have x equals 8. And here I have x equals negative 1. And if I try them both out, they should balance out. Let's use this here. 2x minus 7 equals 9. 2 8s is 16, minus 7 is 9. 2 times negative 2 is negative 2, minus 7 is negative 9. Good job. So both of these answers, negative 1 and 8, our solution for x. And so we'll write them in an ascending order, negative 1 and then 8. Similarly over here, -3 and 7 were solutions. We're going to write them in ascending order, -3 and 7, rather than 7 and -3. All right, so that is about equations. Let's talk about inequalities. So remember, an inequality is just the same thing as an equation, only the sign is greater than, less than, greater than or equal to, less than or equal to, because your solutions are including a range of numbers rather just one specific one. Similar to solving an equation, you're going to do it both a positive and a negative way. So x minus 4 is less than 2, and then we're going to do the opposite way. X minus 4, positive 2 will flip to a negative 2, and remember, anytime we multiply or divide by a negative number, then we flip the sign, and in essence, to get from 2 to -2, we multiplied by a -1. So that less than becomes greater than. And then we solve like normal. X is less than 6. Solve like normal. X is greater than 2. When we get to this point, we need to create a compound inequality of it. So we need to determine, is this an AND situation that's going to meet in the middle and have overlap? Or is this an OR situation that's going to go in opposite directions? Oftentimes, it's wise to graph it to determine this. So x is less than 6. It's an open circle because it's not equal to. And x is greater than 2. So this is an AND situation where x lies between 2 and 6, like so. Okay, let's try another one. Here is an inequality with another term outside of it before we get to the inequality sign. So the wisest thing for us to do is to move that term. So now we have the absolute value of 2 plus 1 is greater than or equal to 9. And now we'll do that the positive way to get 2x plus 1 is greater than or equal to 9, and then flip it. 2x plus 1, instead of greater than or equal to, it'll be less than or equal to. Instead of positive 9, negative 9. And then we solve. And remember, the rule stays the same. If you multiply or divide by a negative as you're solving, you flip the sign then as well. Okay, and now that we have our two parts to the inequality, we do need to build our compound inequality to determine if it's an AND or an OR. Greater than or equal to 4, less than or equal to 5. This is an OR. So we'll write the smaller one first. X is less than or equal to -5, or x is greater than or equal to 4. And those are the solutions that would satisfy this equality. For example, this means any number between 2 and 6. So 4 would fit there. 4 minus 4 is 0. 0 is less than 2. This means I can sub in anything less than -5. So for example, if I have x is less than or equal to -5, we can try -6. 2 times -6 is -12. -12 plus 1 is -11. The absolute value of -11 is 11. 11 minus 3 is 8, and 8 is greater than 6. Or it says x is greater than or equal to 4. Well, 5 is greater than 4. 2 5s is 10, plus 1 is 11. The absolute value of 11 is 11, minus 3 is 8 again. And that's how that works. All right. It's a pretty basic lesson. Not a lot is changing, just a couple subtle things here. Okay, for this first section, it's asking us to use mental math. You do not need to show your work. Don't make this first section more difficult than you need to. I would suggest using this third example that we did in our notes. The absolute value of what number is 8, is 4, is 6.5. So what number or numbers can I find the absolute value of that would give us 8? There aren't any on the back. There's one that could be potentially tricky. Number 4 is asking the absolute value of what number gives us -3. Another way of saying that is what number has a distance from 0 of -3. Is that possible? Doesn't sound like it's possible to me. So it's okay to write not possible. Also, whenever there is a term along with our absolute value, remember to move that over before you figure it out. Okay, for numbers 7 through 15, again, we'll just do them the normal way. X plus 5 is 11. X is 6, and with a negative to get both the directions to find our absolute value. So X is negative 16. So on your worksheet for that one, you will write negative 16 and 6. Smallest and then the biggest one. Okay, for this next section, it's asking you to complete the sentences using the word and or. So the challenge here is to determine, are these absolute values going to point in at each other or point out away from each other? So if I have, let's see, 3 and negative 3, and X is, well, it's going to be going this direction, and this one is going to be going in this direction. Whether or not you know the solution, you know that they're going to point at each other, so this one's going to be an and. Okay, all right. If you look at the next one, solve the inequality, you will do that just like on our notes. The first section says that you do not need to graph the solution. However, I recommend graphing the solution for all of them so you can determine what sort of inequality sign to use. So here, for example, we'll do x plus 4 is greater than 7. So x is greater than 3. So x is less than negative 11. So this is going to go to the right from 3, and this is going to go to the left from negative 11. For those of you who are spatial people, you can maybe envision that that's an or. They're going away from each other, but you may need to graph that out on scratch paper to make sense of that. Okay, it's up to you. But when you write your final answer, please make sure you write then x is less than negative 11 or x is greater than 3. The rest of it you can do on your lined paper. Okay, so similarly for 26 through 31, you'll find your solution and then you should graph. And that's what I mean by graphing. Okay, and then for the next section, these word problems, I think you will be just fine in completing these. We will do one together. It says physicians consider an adult body's temperature to be normal if it is 96.8 plus or minus 1 degree. Write an absolute value inequality that describes this normal temperature range. So a normal temperature, or a person's temperature, is normal if the difference between that, so difference is subtraction, the difference between that and 98.6 is plus or minus, so absolute value of 1. And it can include 1, so we're going to say less than or equal to. And then we can solve this, add 98.6, subtract 98.6, and so we would get our solutions could be 97.6 and 99.6. A person's temperature is normal if it lies between these two numbers. Okay, I skipped some steps there, but I think you'll be okay. And I challenge you to complete 33 through 35. As always, if you have questions, don't hesitate to shoot me an email. I'm happy to help. And I think that's it. Thanks, guys, and I'll catch you in class. Bye.